Good evening to everyone. Myself P. Jain from Department of Mechanical Engineering second year. I am going to give a presentation about losses in transformers under the guidance of Assistant Professor G. Raju sir. Okay, now let's get into the topic. Get into the topics. Losses in transformer. First, what is a transformer and what does it mean? Transformer is a device that transfers electric energy from one alternate current circuit to one or more other circuits, either it increasing or reducing the voltage. This is known as transformer. We have certain types of transformers. They are auto transformers, single phase transformers, three phase transformers, current transformer. These are the different types of transformers. Now let us know about losses in transformers. In any electrical machine, loss can be defined as the difference between input power and output power. An electrical transformer is static device having mechanical losses like windage or friction losses are absent in it. A transformer only consists of electrical losses, iron losses or copper losses. All these losses in a transformer are dissipated in the form of heat. Losses in transformers refer to the energy dissipated as heat during the transformation process. Transformer losses are generally produced by the electrical current flowing in the coils and the magnetic field alternating in the core. The losses which are associated with the coils are called the load losses, while the losses produced in the core are called non-loaders. These losses are classified into two main types. They are copper losses and iron losses. Understanding these losses is crucial for efficient operations and maintenance of transformers. Next, copper losses in transformers. Copper losses occur due to the resistance of the copper windings in the transformers. These losses increases the square of the current flowing through the windings. Minimizing copper losses is essential to the improving the overall efficiency of the transformers. Copper loss is a term often given to the heat produced by the electrical currents in the conductors of transformers, windings, or other electrical devices. Copper's losses are an undesirable transfer of energy, as are core losses, which result from induced current in adjacent components. As we know, losses increases with the square of the current flowing through the windings. By the windings, the increases with the square of current flow will increase. Next, iron losses in transformers. Iron losses, also known as core losses, are caused by the hysteresis and eddy current in the transformer core. Iron losses in a transformer is defined as the loss that which loss is caused by the alternating flux in the transformer core. Due to this, iron loss is also referred to as core loss. For example, eddy and hysteresis current losses are example for the core losses. To further understanding how iron losses happens, let look at iron's magnetic properties. Eddy current losses are induced currents circulating within the core material. Iron loss in a transformer mainly occurs in eddy or hysteresis current losses mostly occur in this. Next, factors affecting transformer losses. The frequency of the alternating current passing through the transformer affects both copper and iron losses. The frequency of the AC currents passing through the transformer affects both copper and iron losses in a core. Look at to the diagram how the frequencies are moving. These frequencies are disturbs the these frequencies are disturbs the transformers in a core, and operating temperature plays a significant role in determining the magnitude of losses in a transformer. Temperature plays a crucial role in determining the magnitude of losses in a transformer. The design and material of the transformer core also influence the overall losses. Next, calculation and measurement of losses. Losses in transformers can be calculated using the mathematical formulas based on the transformer's specification. We can calculate the losses in transformers using the mathematical formulas based on the transformer's specification. Losses can also be measured experimentally using the instruments like power analyzers and thermal imaging cameras. By the thermal imaging cameras and analyzers, losses can also be determined or measured. Regular monitoring of losses is crucial for the detecting any abnormalities in transformer operation. And measurement unit of loss is loss measurements were generally measured in dB. Since dB is a ratio of two power levels, one of which consider the reference value. The dB is a logarithm scale. By using this, we can measure the calculation of the losses and measurements, and dB is the unit of measurement of losses in a logarithm way. Next, impact of losses on transformer efficiency. High losses in transformers lead to lower overfall efficiency and increased energy consumption. Losses can also result in reduced efficiency as the resistance of the transformers winding increases, causing more energy to be lost as heat. This can be to decreased voltage regulation and increased energy consumption, making the transformer low cost of efficiency operators. As we know that efficiency is defined as the ratio of output power to input power with losses factored in it. Minimizing losses through proper design, maintenance, operations enhance the efficiency of transformers. We can minimize the losses through the proper design and maintenance and the operation enhance of the efficiency transformers. Like this, we can maintain the transformers properly with high quality materials, and we can minimize the losses through this a certain way. Next, mitigating losses in transformers. Employing efficient cooling methods such as oil or air cooling can help reducing losses in transformers. These cooling methods such as oil or air cooling can help reduce losses in transformers. By using these methods, we can reduce the losses in transformers by cooling method process. Using high quality materials and proper insulation can minimize losses and improve the transformer performance. We can, by using the high quality materials, we can minimize the losses and improve the age of usage of the transformer performance. Regular maintenance and monitoring of transformers are essential to identify and address any issues causing excessive losses. Regular maintenance, we can find out the we have any problem in the transformers. We can find out the problem, and we can solve the problem by through the regular maintenance and monitoring of the transformer. So this can also less losses in transformer. It is a good pretty way to stop losses in transformers. And using high quality materials and proper insulation can minimize the losses and improve transformation performance. We want to improve the transformer performance by using high quality materials, and also regular maintenance contains a good work of transformers. Conclusion. In the above presentation, we discussed about the transformer types, their losses and methods to reduce them. The typical transformers has the efficiency of 80 to 90%. We conclude that transformers can achieve efficiency about 98 to 99 if the applications and precautions applied carefully. Cooling transformer properly, shedding of core must be greater, resistance of the winding and must be lesser, primary and secondary windings must be interleaving, and regular maintenance and using high quality materials can also reduce the losses in transformations. And this is about my presentation. Thank you for giving this golden opportunity. Thank you, sir.